Okay, today we're going to be talking about rates and unit rates. We've got about 4 vocabulary words today that we need to work on so we can work effectively with this lesson. The first being conversion factor. Now, a lot of people actually know what they are, but they've never heard that vocabulary word before. These are actually fractions where the numerator and denominator represent the same amount, but they use different units. So if I said something like 1 day, what's another way that would reflect the same thing as 1 day? Hopefully you would tell me 24 hours. Those are 2 different units, but they represent the same exact amount. So 1 pound, 16 ounces. 7 days, 1 week. And if you're ever a baker, 1 tablespoon is the same as 3 teaspoons. So those are what we call conversion factors. It's a fraction where the units on the numerator and denominator are different, but they represent the same amount. The next vocabulary word we're going to look at is rate. And a rate is a ratio. We talked about ratios in 3.1, usually written as a fraction, comparing 2 things. Well, these also compare 2 quantities, but they're measured in different units. Where before with a ratio, sometimes they are the same unit, sometimes they're not. Sometimes we can make them into the same. Well, when we can't make them into the same, it's a ratio, but it also could be called a rate. So like 20 minutes in 2 miles. I ran 20 minutes and I got 2 miles away. Or I went to LA and I drove 117 miles and it took me 3 hours. Or I bought $3 and the grocery store got me 1 dozen donuts. Those are where those rates or those units are different. They cannot be made the same, and they're comparing one thing to another, and those are called rates. Well, a unit rate is a ratio. Again, those 2 units cannot be the same, but it's where the second term or the denominator, the bottom, is 1. When we make it 1. So looking at those ratios above, like 20 minutes for 2 miles, I need to make that denominator here a 1. The only way to make it a 1 is to divide the top and the bottom by 2. And when I do that, I get 10 minutes over 1 mile. Well, that 1 mile down here, that makes it a unit rate. My denominator is a 1. So I can leave it that way, 10 minutes to 1 mile. Or many times you will hear people say, oh, what was your time in PE? Oh, I got a 10-minute mile, 10 minutes per mile. That is a unit rate. And that little line there for that fraction stands for the word per when I'm talking about those ratios or those rates. Same thing with the other one, LA, 117 miles in 3 hours. Well, get that bottom to be a 1, so divide top and bottom by 3, and I get 39 miles over 1 hour. Or how fast I was going is at 39 miles per hour. And that last one with the money and the donuts, it already looks like a unit rate because I've got a 1 on the bottom. But hopefully you weren't tricked, because a dozen is not 1. A dozen is 12. So to make it a unit rate, I actually have to divide the top and bottom by 12. And when I do that, I will get 25 cents for 1 donut. That is a unit rate. So again, I could write it like that, or 25 cents per donut. That's what we call a unit rate. Now, our last vocabulary word is a complex fraction. And a complex fraction is a fraction that has a fraction in the numerator, the denominator, or both the numerator and denominator. So if I had a fraction in the numerator, or a fraction in the denominator, or a fraction in the numerator and denominator, those are what we call complex fractions. And that's really what I'm going to have you work on first in this lesson. And that is simplifying the complex fraction. Many people get very nervous when they see a fraction over a fraction. But look at the step. The first thing I want you to do is I just want you to write that complex fraction as a division problem. So let's go ahead and get rid of it so it's not on top of each other. Let's write it what it is. A fraction is a division problem. We know that. That line right here stands for a division problem. So really, the numerator is being divided by the denominator. So instead of putting it on top where that complex fraction can look so confusing, I'm just doing it horizontally, writing it as a division problem. Now you see those fractions, and you know I don't ever divide with fractions. I'm going to change the problem to use that multiplicative inverse. Remember, we changed the dividing to multiplying, and then we need to go ahead and change the second fraction here to its reciprocal. So 1/2 divided by 3/4 is really 1/2 times 4/3. Now I know once I changed it and did step 1, you were like, oh my goodness, I know what to do on this. Again, things can look really confusing unless you actually are explained how to do them. And now we're going to multiply and simplify. So let's go ahead and multiply 4 over 6. And then can I reduce it? Absolutely. 2 goes into both, which will give me 2 over 3. So my answer for that complex fraction is 2/3. So we're going to work with complex fractions, but we're also going to be using our unit rates. So in example 2, I'm saying let's find our unit rate. So the first thing I need you to do is to write it as a ratio. And the thing you have to remember is whatever comes first or goes on the top. Whatever comes second goes second or goes on the bottom. I said earlier, the only time that is different is if money is involved. If there's money, no matter where that is, it always goes on top. So let's go ahead and look at this one. I don't see any money here. Text 120 words in 3 minutes. Okay, so I've got 120 words is first. So I'm going to go ahead and write that down first. That's going to go on top. And then what comes second is that 3 minutes. So that goes on the bottom. Now, again, unit rate means I have to go ahead and get that denominator to be a 1. So I'm going to divide the ratios, the numerator and denominator. So I'm making that denominator 1. So let's go ahead and divide top and bottom by 3. When I do that, I should get 40 words over 1 minute. So I can leave my answer like that, or I can write it 40 words per minute. So again, we're finding the unit rate of the situation. So let's go ahead and look at that next one. Again, whatever comes first goes first, whatever goes second, except if there's money. And I can see money right here, which means even though it comes second, I'm going to put that on top. So $3.50 is going to go on top, and my 5 pounds of bananas, that's going to go on the bottom. Now let's make it a unit rate by getting that denominator to be a 1. So that means I'm going to go ahead and divide the top and the bottom by 5. And when you do that, you should come up with 70 cents per pound. That would be the unit rate of those bananas. You're really paying 70 cents per pound, which is not a bad price. Now, the last thing I want you to do is to be able to find the best buy, because in life, this is really what's going to matter when you're doing your math. And that is, I don't like to work hard to just throw away my money. I want to get the best deal I can, and that's what we're looking at here. So I'm giving you 2 different items. In A here, I'm giving you $3.89 for 16 ounces of cereal, $1.55 for 6 ounces of cereal. Now, many people say, oh, well, the cheaper one is, get the cheaper one, save money. But I have to know the unit rate. How much am I really paying per ounce? And am I wasting my money by getting the cheaper one, or is it saving me money? So I'm telling you here in step 1, we're going to find that unit rate for each. So I took that first one. Again, money always goes on top. So I've got my $3.89 divided by my 16 ounces of cereal. I'm creating that unit rate by dividing the top and the bottom by 16. But I have to be very careful because since I'm talking about money, remember, money can only have 2 places after the decimal. So I have to round to the nearest cent. And it is okay to use a calculator for these when I give it to you on your work today. So yes, you can use a calculator. So on the calculator, it's going to give you 0.243125. Again, I can only have 2 places. So after the 4, I look at the one next to it. If it's a 5 or bigger, I have to make the 4 go to a 5. If it's under 5, it stays the same. So here, that's giving me 24 cents per ounce. So let's look at that next one. $1.55 for 6 ounces. Let's go ahead and create that unit rate by dividing top and bottom by 6. And if I get my calculator out and I divide 1.55 divided by 6, I should come up with 0.258333, and it goes on and on and on. But I don't care about that. I know I only can have 2 places after the decimal, so I really only need 3 numbers, because if I look at that number next to the 5, it's an 8, which means that is going to increase it. So this would be 26 cents per ounce. So that tells me right there, although $1.55 is cheaper, I'm actually going to have to buy more boxes of that to get the same amount of cereal. So the best buy for me is not to buy the cheaper one. The best buy, which is exactly what we're trying to do, the best buy is to get the $1.55 box of cereal. Or you can write down the cost, or it's the 6 ounce box of cereal. That one is, what am I doing? Come on, guys. It's the 16 ounce, box of cereal. This is the one that saves me money. I save 2 cents for every ounce if I buy that one. So it is the 16 ounce. I was just checking to see if you were paying attention. 16 ounce box of cereal is my best buy. So let's go ahead and get ready to work on that today. Bring any questions with you if you have.